So, hello everyone. I hope that you can hear me all right. All right, perfect. So, yeah, thank you for coming to this talk. This is called Podman, Living the Talk. I'm Daniel. I work for Recon. We're a tech company based in London. Do check us out if you're interested. And yeah, we're going to go over Podman as a tool in general. We're going to go over some of its features, how it compares to Docker proper, let's say, and what advantages and disadvantages it may have for your concrete use cases. I know there are Red Hat engineers in the building. I hope I don't do your product too much of a disservice. And yeah, without further ado, I'll go straight in. So, Podman, what is this thing? So it's a tool to manage containers and images. Now, I don't really like the word tool. Tool is a very generic and really non-descriptive word. A hammer or a screwdriver are tools, and they certainly have nothing to do with containers or with tech. So what does it mean for this to be a tool concretely? Well, the point is that it bundles a bunch of things which make it possible for you to work with containers. So in practice, this means the command line utility, which is pretty much a drop-in replacement for Docker. So whenever you use Docker for whatever, Docker build, Docker run, Docker PS, all of these different utilities are kind of bundled under the same namespace. That's kind of what it does. And under the hood of this CLI, there's a bunch of different utilities which work for building those containers, running those containers. So there's a builder, there's the container runtime. Podman kind of groups them all together, and what you will be accessing through Podman is all of these utilities underneath, packaged under the command line utility. So as I mentioned, this is mostly a drop-in Docker replacement. You won't find many issues if you try to just replace all of your Docker commands with Podman alternatives. They work in very much the same way. That's kind of the point. And yeah, we'll go over some of its, let's say, particularities or some of the corner cases in later slides. So why am I speaking about this? Why me? And why? What reason do I have to be speaking to you about this? So, in one of the projects that I manage with the Workflow program, we had a pretty much perfect use case for Podman. So we had an on-prem Red Hat machine. We didn't really have root access, and our security measures are kind of strict due to this being an NGO. And requesting for this root access and trying to work within that framework was a bit harder than usual. So this is kind of pretty much the perfect situation you can get if you want to work with this tool. So we took the plunge and decided to work with it. So I'll start going over the differences between Podman and Docker. One of them you might think is the licensing. Actually, not quite. So this gets a bit confusing due to the fact that Docker Inc. Is a company, and then they have Docker, the product. But it's not the only product of the company, and some of them are open source, some are not. In the end, the only exception or the only difference will apply if you're using the desktop versions. So Docker Desktop, you will need a license for that in certain conditions. With Podman, that doesn't apply. So if you have, if you're one of these GUI tool users, you might be interested in checking this out because you will sidestep a lot of potential licensing issues. For all other cases, not really much difference. All of the Docker source code is available under Moby. That's what you see here. So it's not called the same thing, which adds to the confusion. But this is essentially what you have when you work with a Docker base. And that tool is licensed under the Apache license. And actually, Podman is also under the Apache license. So that's as far as differences within licensing go, which is to say that there are basically none unless you specifically target the GUIs. So where does the advantage, or in what ways does it differ from Docker, if not the licensing? Well, in order to speak about that, I will need to go a bit into the Docker daemon. So what is this in the first place? What's a daemon? I'm a web developer, so I'm not a OS programmer, not a systems programmer. So these things are also kind of abstracted from what I usually do. But if you're in the same situation, you can think of a daemon as a background service. So it's something that's running on your operating system right there in the background, and it normally exposes a socket from which programs can access and execute different tasks. And Docker has one. So what you see here is my own machine, and as long as as soon as I start my machine, I have the Docker daemon active. It's right there, as you see, it's running. And when I start a container, you will notice that if I check for the process ID of this process, it's started by root. So this means that the Docker daemon is it's not really a user service. It's started by it does have super user permissions. This is relevant for there you go. This is relevant for what we'll see later. This is a further overview. As you see, when I get a container in, it's under the tree of the processes of the Docker daemon, and you'll notice that the actual program that starts the container runtime has been spawned by the Docker process. Now, the first relevant difference, and arguably the biggest, with Podman is that Podman is Daemonless. So what you're seeing here is the same image I was showing you before. It's a relatively, it's a bare bones Alpine container. It doesn't really matter what's inside. The point is that you will see that this has been spawned or kind of forked from, not from a daemon. It has been started by the user space. Now, this seems a bit superficial if you think about it at first. Like, why do we particularly care about this? There are architectural reasons why that might matter at the operating system level. For your user level, the big gain is that it's rootless. So if I check for the process ID that I started, and I check the process ID of the runtime that's executing the container, you will see that the user right there, it's me. It's not root. That means that that container or that process has the same permissions as my regular user. It doesn't have super user permissions. And even if there's, let's say, a breach in the container, or you find a way to kind of to go into the container and to maliciously try to access something that you shouldn't have access to, you're kind of sandboxed from that, from the user's perspective. Now, I want to clarify that this doesn't mean that the container user is not root. These are different things. One thing is the container runtime that's running on your machine. Another thing is the user that's inside of the container and that's executing whatever your container is doing. That's kind of not relevant for this point. In any case, worth clarification. Another thing that's worth mentioning is that Docker can also be run rootless. It does take a bit of setup. You have the link right there. It's not entirely trivial. It's also not very complicated, but then again, it's not built with that in mind. And if you need a use case, or you would think that it's advantageous for you to have a use case where you don't overstep the boundaries of your regular user permissions, you might as well go with a daemonless service instead of having to kind of backtrack your way to a working setup with this. It still can be done if you're interested in that. So now that we've seen this, I want to go over the different orchestrating tools that you can use to launch your containers. So we have seen how we can execute a container, and that's just one, and it's there. But what happens if I want to set up several containers at the same time in my machine? Well, this is where things get a bit more interesting. We're going to see different avenues or different ways in which you can do all of this, from, let's say, less recommended to more recommended, or from less Podmanic to more Podmanic, if you really want to see it that way. The first thing I want to clarify, or that it's good to point out, because I don't think it's all that well known, is that Compose is different from Docker. It's not really the same thing. Compose, it's its own spec, And until relatively recently, in fact, you actually had to install in most distributions the Docker dash compose command separately. In fact, it wasn't under the Docker namespace. Docker space compose wouldn't do anything, wouldn't work. Or in the best case scenario, it was alias, but it was calling that underneath. Nowadays, it does come with it. If you call Docker space compose, it will work. But the point of all of this is that it's not the same thing. It's not under the same command line namespace, and it works in a, let's say, different way. It's not inherently related to Docker. What that means for us is that this Docker Compose tool is made to work with a daemon, and Podman by default doesn't have it or doesn't activate it. So I said that Podman is daemonless. I kind of lied. It does have a daemon. It's just disabled by default. So what you're seeing there is the daemon in my machine. As you see, it's stopped. It's disabled. And I'm not using it. I don't have the need to. But if you want to have an even bigger, let's say, one-to-one mapping or one-to-one behavior from Docker and Podman, maybe this is one of the first things that you might be interested to check. If you activate this daemon, it will work in very much the same way as Docker does. All the caveats and kind of cons apply if you're interested in having it be rootless. You can also start, let's say, user service daemons, but then again, you're kind of stepping into muddy waters. So you can use, the point of all of this is that you can use Docker Compose, and this means Docker Compose, to run containers with Podman, as long as you activate the service. However, this is slightly, this is kind of the worst alternative in the sense that you are forced to activate this daemon, and we kind of want to avoid that if we want to be clean. The second tool that you have at your disposal is Podman Compose. Podman Compose is different, and it takes care of some of the pain points or some of the structural or architectural problems that we saw before. So this is made to work without a daemon active. It's specific for Podman, and it's developed by the same people. And it will start all of your containers. It will take a compose file, and it will start all of your containers using processes, also in rootless mode. So you won't have to activate that daemon that we saw before if you don't really want to. Now, this is, even though this is already quite good, and most people, I think, would be satisfied with this, if you really go into the communities, if you read the forums, ask the developers, and go into people who actually work with this a lot, it's slightly frowned upon. The reason for this is it's easier to justify from the operating system point of view than from the container operator point of view, let's say. So the point of all of this is that the operating systems already have a process manager. And that's part of the reason why they don't want a daemon in the first place. Your operating system already has, if you're using Linux, it's going to be probably systemd. And that's going to be holding services, processes, going to be taking care of which process ID holds which process, etc. And the argument goes something like, we don't really need another tool, or we don't really need a higher abstraction layer to hold all this information for containers for us. It should be the operating system's job to do this, not an external tooling. We should not really treat containers like second-class citizens, and we shouldn't need an additional tool to handle all of this for us when we can leverage on the Unix tools to be able to work with us in that sense. So that's more or less the argument. How much of that you want to buy, or how much of that matters to you, I guess it's, again, up to you. But the Podmanic solution, or the proper tooling, the proper way that they want you to do this, is by using Quadlets. Now, what's a Quadlet? It works essentially in a very similar way to systemd services, if you've ever seen one. If you haven't, you can just probably cat your etc/systemd/whatever. You'll see what I mean. And the description that you see in this GitHub repo, which is, by the way, now deprecated, but I pulled it because I think the text that you see in why would I want that is actually very much clear-cut. It's what I explained to you before, and it's the reasoning that they're following in order to justify this tool existing. And the way that it works and the syntax that it uses is the same as a systemd service, except you do have another entry. So you have a container entry, and in that you will put all of your container-specific settings, configurations, etc., in order to have the operating system take care of that, of the launching, and of the management of that container. So let's say that apart from this sometimes intangible benefit in terms of who's handling what process, what other advantages or what other things do I get? What leverage do I get out of using Quadlets instead of just composing my containers? Well, this allows you to do some really cool things. For example, you can schedule automated updates, and those will be orchestrated by your operating system. So you can tell your OS, update the base image for this container every whatever time. And that runs essentially the same way as any other automated updates for your operating system would. It's more or less indifferent by that point, and it's all orchestrated by the system layer, not necessarily the kind of the Docker layer or the tooling that's one level above, because we don't really make use of that. So that's I guess the justification and the optimal tooling in order to use Podman. But there's, let's say that the flip side of this, from my experience as a web developer, is that systemd services are, as you see, a bit verbose. And they describe one container. They don't really describe a set of containers or, let's say, an orchestration of different containers. If you do want to launch several containers at the same time, you will have to create one of these for every container that you want to have. It's not necessarily hard to do, but it is a bit verbose. And it runs into some, let's say, developer experience quirks. For example, if I distribute my compose file to you, you can just do docker compose up, it will work, and that's the end of it. What do you do with this precisely? Now, you do have to drag it into your machine. You have to copy it over. Do you provide a script in order to do this automatically for you? It's a bit less terse in terms of developer experience and how you actually want to distribute your work and work locally. For local and application development. For things like production systems, this is very, very fancy and very elegant. You do get the reliability of the base system layer, and you don't have to maintain an extra process with all of the niceties that I mentioned before. You can schedule automated updates. You can leverage all the system service syntax in order to keep your containers managed at that level. There's more, like the TV advertisements. You have Podman Cube. This is a very fancy feature, and I think it's quite underutilized. So you can instruct Podman to work and to interrupt with Kubernetes very much straight away out of the box. So you have a couple of commands. As you see, you have you can generate, you can apply. We'll see examples of this now. And you can create a container. You can use Kubernetes YAML to create those containers. You can also do it the other way around. You can have your containers and then extract or generate some Kubernetes YAML in order to have that. And the result is something like this. So I am now taking the same process that I had before, the same Alpine container, and I'm piping it out to the consoles just so you can see what goes on. As you see, it's a very YAML-y Kubernetes YAML. And the point of all of this is that, of course, you can save it and you can replay the same. You can replay the same configuration that you had before in, and it's actually a Kubernetes pod. So check this out. If I take it out to a file and then I run Podman play, and I check my processes, you will see that the same container has been launched. It is now a Kubernetes pod, so it's not just a container. This is actually a real Kubernetes pod, and you can interact with it in the same way that you would do in your production systems and things like that. Caveat, of course, is that, or side note, you will need an actual control plane to actually interact with this. That doesn't really come out of the box, obviously. So you can use whatever. You can use Minikube or Kind or I guess kubeadmin if you're a gangster like that. But for the rest of us, I think the rest of the utilities will be more than enough. All right, so I think we've gone over most of the specific and different, all of the differences that Podman has compared to Docker, all of the extra quirks. As I mentioned before, the rest of the CLI is more or less one-to-one. So if you do Podman build, it's not like you build a different kind of container. There's no such thing actually as like a Podman container or a Docker container. These are all just generic containers. There's a standard for generating container images, and it's all the same no matter what you use. The runtimes are slightly different, but that's nothing that actually matters. They work in very much the same way, and you'll be very, very hard-pressed to find any runtime differences between one and the other. Also for things like performance, I think in most of the cases, it won't matter. You might argue that not having a background running service is slightly more performant, but then again, it does also give you a service to hit when you need to do things like Docker PS or something. So there are slight trade-offs, and if you're really interested, you can go into this and try to find the nitty-gritty bits, but for 95% of the cases, completely irrelevant, and it works in very much the same way. So what things do you have to look out for when you're using this? Because even though, as I say, it very much operates in a similar way, there are some quirks that you need to be on the lookout for, especially if you use rootless mode. The first one is networking. Now, there are some things you cannot do in networking if you use the rootless mode. The full documentation about that is linked there if you're interested. Most of those are not really important, or you won't find them in your day-to-day use cases. At least it didn't happen to me. But the ones that you might care about is slightly reduced performance. You have to go through a different interface, so that might slightly throttle. Again, not very important unless you have very, very high throughput I/O, network I/O. Still something to keep in mind if that's your use case. And another thing that you might notice is that, at least it happened to me, if you use one of the container like orchestrating tools, so Podman Compose, Docker Compose, particularly Podman Compose, some of the networking, you might find some head scratchers. Nothing that's too hard to solve. If I was able to solve those, you will also be able to solve it, I'm sure. But it's something to be on the lookout for. These things are to be expected, and it's something that you might find. Next is volumes, and this is, I think, also expected if you are trying to do rootless stuff. So I've cropped a part of documentation there so you can read it, but the gist of it is that whereas before we had root access, and when we mounted volumes, we could do more or less whatever we wanted, at least from the tooling level. So Docker is more or less free to do whatever it wants with the volumes you mount because you are doing it through a rootful service. If you launch your containers in rootless mode, or if you use a rootless tool to orchestrate your containers, you might find your operating system halting you from, or preventing you from doing those kinds of things. This is likely dependent on the operating system. Some use AppArmor, some use SE Linux. SE Linux is more restrictive, and that's where you might find most of the issues, in case you do find them. I will say nowadays, most of the distributions bundle policies with the container tool that you install so that you never find this in practice. So I would say it's quite rare that you actually get into something like this, and maybe you have to be doing very evil things in order to find hard to track bugs with this. But be on the lookout that if you find your volumes not working, or you find something that doesn't quite add up, this might be the culprit. Just be mindful and don't just completely disable your operating system's kind of file access security. That's bad, don't do that. Put in the time to kind of fix the actual issue, and don't throw the baby out with the bathwater. Lastly, there are some problems with images. This is also extraordinarily rare, and I think the image has to be kind of almost intentionally built wrong in order for you to find things like this. But there are some images that are built with Docker in mind, and that will leverage the rootful access in order to operate. Again, I think that's probably not the tooling's problem, and I think that in practice, it's extremely rare that you do happen to come across one of these images. But it might happen, might exist. If you're using one of these, you can, I don't know if you can read the thread from the back, but I can send you the link after if you're interested. In any case, not very common, but some images are built with kind of rootful execution in mind. Be on the lookout for that. So this is almost all, and I have some closing thoughts, some kind of some conclusions about all of this road, all of these things that we have seen. How does this all play in practice for people like me? In my case, as I mentioned, I'm a web developer. So in what situations am I able to leverage the advantages, and in which situations does it get in my way? So I think there are a couple of very legitimate reasons to want to use Podman. The first off is if you're starting a new project, I really don't see a reason why you would start something new and not want to have it be rootless by default. It's not really hard to set up. You won't find any migration issues from one tooling to the other, and it's just more secure and, in general, better practice to have your containers be kind of rootless and your servers to be rootless. So I think if you're starting a new project, probably very legitimate to just use Podman for that. The second case is what happened to me. If you are exposing containers, if you have a machine that's exposing containers and you have it on-prem and you are not leveraging on managed service to handle your container workloads, in which case that should be taken care of, security issues should be addressed by your provider, not necessarily the tooling. But if you have an on-prem machine and you're running a container and you're exposing that somewhere, I highly recommend that you kind of go rootless. It's not people are working with Docker images and Docker services all day, so it's not the highest of security risks. But in this day and age, and with this tool working in a very seamless way, I don't see why you would want to put yourself in that situation. Probably much better to leverage Podman's advantages in this case. And you also get some of the nice system-level integrations, in case you're interested in that. Next up is if it comes with your distro. If you're using like Fedora or any of the Red Hat Linux distributions, it's already there. And in fact, if you try to install Docker, it will install Podman. In that case, probably don't bother. I would say that you won't find any issues. It's very likely that you won't find any issues with Podman, and the time that it would take you to install Docker will probably be longer than just using Podman as it comes. So in that case, probably very legitimate for you to continue using it and not care so much. Another use case, as we saw with the licensing, is if you care about the desktop version. Personally, that's not my case, and in fact, I would slightly encourage people to lose the fear of the command line if that's your case, particularly for something like Docker. There are some other utilities, for example, Kubernetes, which do require more knowledge. You do have to know what you're doing, and the command line, let's say, breadth and the surface area is much bigger, so it's harder to get used to it. But for something like Docker, which is it's very simple, I would say lose the fear of the command line. Don't necessarily reach out for these GUI tools if you'll need them. For most of your daily operations, it's going to be a very small subset of commands that you will actually need to use. Run, stop, build. These are very easy to grasp concepts and easy to type it in. So I would say that's my preference, at least. But then again, if you are using the desktop versions of these tools and you care about licensing, that's another case. And finally, if you do want to leverage off of some of the those Quadlet features and cube features that Podman has, I think this is, in my experience, as I said, I think the developer experience may not be quite there. I think it's still a bit too hard to grasp and hard to get into for people who are not really working with this day to day. And I don't know how much benefit you will get out of having the same Kubernetes setup in your local machine as in your web servers and in your production workloads. because I don't know how many bugs you will find that actually have to do with Kubernetes itself and not the app that you're developing. So the usefulness of this is, the usefulness and the developer experience and the way you set this up is, I think, still a bit maybe not worth the effort if your team already uses a simple compose setup. But then again, if you really do want to get fancy and if you find that you will have use cases and legitimate reasons why you would want to replicate Kubernetes setups locally, this tool is fantastic. And you know, I really recommend you take a look. And yeah, that's all I have for today. I'm open for questions, and thank you for listening.
Hey, thanks for the talk. It's less a question, more a remark. I've been doing a project where we've been running, or still running, all Debian, and I wanted to get rid of Docker and migrate to Podman, where I started off with the system, and it all was the same you said, so I could easily install Podman without adding the Docker repo and stuff like that. And like after 6 weeks, I found a major problem which wasn't working. So to cut it short, don't use Podman if you're on Debian, because they still stay with version 1 and there is no update to version 2. So I had the problem, I wanted to run an Nginx with just limited access rights, and there was no means of getting the public IP to the Nginx. And it's not solved, so it doesn't work on Debian. And I found out after 6 weeks that it's not the way to go. I can't find a solution for it. There's a long-standing bug to do it. So yes, your slides are good if you run Fedora or Red Hat Enterprise, but it's a no-go for Debian. So still, I took all the lessons learned with the way Podman approaches the problem, limiting user rights, and I reverted back to Docker for Debian, and used all the things I learned here with user NS mapping. I still stay with the Docker running root, but doing user NS mapping for each and every container, so they are forced in their own namespace and user space, while the Docker container still runs root. So that's just my experience I wanted to share. If you're using Debian and you can't afford to just switch your operating system if your entire backend is set to this, then be careful.
Mm-hmm. Yeah, no, thank you for that remark. That you actually bring up a couple of that actually brings up a couple of good conversation points. On one hand, you know, my knee-jerk reaction was, well, what kind of problem did you find concretely that you weren't able to solve? And I, you know, as soon as you said that you were using version 1, it kind of made sense. So one thing that I think it's good to mention is that this tool has been evolving very quickly, very rapidly. So for reference, Podman is now in version 5. And in fact, in order to use Quadlets, I think you need at least version 4. If you want to use Quadlets with Kubernetes syntax, so let me go back and actually show you what I mean. If you do want to use actual Kubernetes syntax within your Quadlets, you can, but you need Podman 5. So FYI. So yeah, your Debian is 4 versions prior. So that's one of the reasons why I think the time for a talk like this was now and not 2 years ago. I have been following this tool for a while, and it is correct that a couple of years ago it wasn't straightforward at all, or at least not so much, and you would used to find a lot of hurdles like the ones you mentioned. By the way, related to networking, which is I think one of the pain points if you really find these bizarre problems. The number one tends to be related to networking. So yeah, I mean, I agree with everything you said. I think it's correct. Although I think let's say the core of the issue is that the version that's being used is probably so old that those problems are not relevant anymore. At least if you're using a current version of the tooling. But no, yeah, thank you for sharing, because that's very true. This has evolved really quickly. They have moved very fast. A lot of these features are very new, and this didn't used to be the case 2 or 3 years ago. I did find more problems, and this is the first time I have been able to successfully use it in production, and it's because of the rapid development. It wasn't always like this. So yeah, agreed.
Yeah, thank you very much for the great talk. Regarding the Docker desktop comment, so do you happen to know that there is like Podman desktop also available? So maybe you can share feedback if you use it, or if you're a CLI guy and you're not using it, that would be also a good comment. And like, what operation system you're using Podman with? Like, not in production, but for development, I mean.
So yeah, maybe this wasn't clear when I mentioned it. This is my fault. So when I talk about the licensing of the desktop versions, there is a Podman desktop, and that's that's under the same license as the command line. So it does exist. It does integrate with things like the Kubernetes stuff. So it's a very interesting tool too. I personally don't use it, as I mentioned before, but in case it wasn't clear, like yes, Podman desktop does exist, and it's free from licensing, let's say, issues, which the Docker one isn't. So so yes, and then for in my local development, I use OpenShift, but and it works fine for me. But you know, let's say that the home of this is usually Red Hat systems, but you know, OpenShift is not directly one, and I've been using it just fine. I think there also used to be issues related to permissions in within Debian and Ubuntu, not related to old versions, but related to actual integrations with AppArmor and SC Linux in the previous versions. But I think that's solved by now. I think it's very much you can use it in whichever operating system you wish. So, yeah.
Yeah, hello. So you said it's a drop-in replacement, yeah? So we switched from Docker to Podman, and we detected one slight difference, yeah, that I might mention here for everyone. So when you call Docker info or Podman info, the result is completely different, yes, and when you have tools which pass and rely on Docker info or Docker Podman info, yeah, you need to take care of this, yeah. And we're using JIP, Google JIP, to build Docker images, and they did not come with Podman info support. So it's broken for months, and they didn't fix it. So when you're using JIP, you need to stay on the old version currently until they fix it. I don't know when. So that's when we stumbled across. Yeah. So might be helpful for someone else. Yeah.
Yep, that's true. That's a fair comment. I didn't think that, or I didn't run into any tooling that used the info command. But it is true. Like I have used the info command a lot actually, because it does tell you, for example, whether your containers are actually, or whether your service is actually rootless or not, whether your container is actually running in rootless mode. So it is quite different. It is true. I didn't know that this could cause trouble with external tooling. I can imagine how that is the case. So yeah, I agree with your comment. It's correct.
So it's a new feature in JIP. They just put it in the last version, and that doesn't check for Podman info. Yeah. So.
All right. So I think that's all. Thank you again.